Did you know that trees talk? Not with rustling leaves or creaking branches, but in a silent language, hidden beneath the forest floor. Trees, those giants of the plant world, are more social than you might think. They send messages, share resources, and even warn each other of danger, all through a vast, intricate network. Imagine a world where information travels through roots and fungi, where trees nurture their young and band together against threats. This is the hidden world of the forest, a place where trees communicate and cooperate for the benefit of the entire ecosystem. This secret network, often called the Wood Wide Web, is a fascinating example of the interconnectedness of nature. It's a reminder that even in the quietest forest, a silent but vital conversation is taking place. So the next time you walk through a forest, take a moment to listen. You might just hear the whispers of the trees. Beneath the forest floor, a hidden world thrives. It's a world of intricate connections, a bustling network of roots and fungi that spans vast distances. This is the Wood Wide Web, the internet of the forest. Think of it as a vast underground network of fiber optic cables, but instead of carrying digital information, it carries life-giving resources and chemical messages. This network allows trees to communicate and interact in ways we are only beginning to understand. Trees use this network to exchange nutrients, share information about droughts or insect attacks, and even support their offspring. It's a complex and fascinating system that highlights the interconnectedness of the forest ecosystem. The Wood Wide Web is a testament to the power of collaboration in nature. It's a reminder that even in the seemingly solitary world of trees, there is strength in connection.
At the heart of the Wood Wide Web lies a fascinating partnership, the symbiotic relationship between trees and mycorrhizal fungi. These fungi, with their thread-like mycelia, are the master networkers of the forest. Imagine a network of tiny, interconnected threads weaving their way through the soil, connecting the roots of different trees.
These fungal threads, called mycelia, act like underground highways, transporting water, nutrients, and even chemical signals between trees. The fungi benefit from this relationship by receiving sugars from the trees, which they produce through photosynthesis.
In return, the fungi provide the trees with essential nutrients such as nitrogen and phosphorus, which they are more efficient at extracting from the soil. This mutually beneficial relationship, known as symbiosis, is crucial for the health and survival of both the trees and the fungi. It's a beautiful example of how cooperation and interdependence are essential for life in the forest.
In the forest, sharing is not just caring, it's essential for survival. Trees, through their connection to the Wood Wide Web, engage in a remarkable display of resource sharing, ensuring that everyone has enough to thrive. Imagine a mother tree, its roots intertwined with a network of fungi, sending nutrients to its young seedlings growing in the shade below. Or picture a dying tree, its last reserves of energy being pumped back into the network, providing sustenance for its neighbors. This exchange of nutrients is not random, it's a carefully orchestrated process. Trees connected through the Wood Wide Web can sense the needs of their neighbors and adjust their nutrient flow accordingly. Through this intricate system of sharing, trees create a more resilient and stable forest ecosystem, ensuring the survival of the entire community. A taste of danger, warning signals in the air. When danger lurks in the forest, trees don't just stand idly by. They've developed sophisticated warning systems, using air and underground signals to alert their neighbors about impending threats.
Imagine a cloud of volatile organic compounds released by a tree under attack by insects, carried by the wind to neighboring trees. This airborne signal acts as a warning, prompting nearby trees to ramp up their defenses.
But the communication doesn't stop there. Trees can also send warning signals through the Wood Wide Web, using chemical and electrical impulses to alert their underground neighbors. These early warning systems give trees a fighting chance against pests and diseases, allowing them to prepare for attack and minimize damage. It's a remarkable example of how trees have evolved to cooperate and protect one another.
In the heart of the forest, mother trees play a vital role in nurturing the next generation. These elder stateswomen of the forest, connected to a vast network of younger trees, act as hubs of wisdom and sustenance.
Imagine a towering mother tree, its canopy reaching for the sky, casting a nurturing shade over a group of seedlings below. Through the wood-wide web, the mother tree can identify its offspring and provide them with essential nutrients, giving them a head start in life.
These mother trees don't just provide food, they also act as mentors, sharing their accumulated wisdom and helping their offspring thrive in the competitive forest environment. The presence of mother trees is crucial for forest regeneration. They ensure the survival of the next generation, passing on their genes and knowledge to shape the future of the forest.
It turns out that trees, like humans, can recognize their kin. They exhibit a fascinating ability to distinguish between the roots of their own offspring and those of unrelated trees, favoring their family members in the underground network.
Imagine a group of seedlings, their roots intertwined beneath the forest floor. Through chemical signals and root recognition, trees can identify their siblings and even their parents, fostering a sense of kinship in the forest.
This ability to recognize kin allows trees to allocate resources more effectively, supporting their offspring and ensuring the survival of their genetic line. It's a testament to the complex social interactions that take place beneath the surface of the forest. The next time you walk through a forest, remember that you're not just surrounded by trees. You're surrounded by families, each with its own history and connections. Trees may seem like passive inhabitants of the forest, but they're far from defenseless. When threatened, trees can deploy a range of sophisticated defense mechanisms to protect themselves and their neighbors. Imagine a caterpillar taking a bite out of a leaf. The tree, sensing the attack, releases a cascade of chemicals, making its leaves less palatable to the hungry herbivore. But trees don't just fight back chemically, they can also enlist the help of their allies in the animal kingdom. Some trees release pheromones that attract predatory insects, which then prey on the pests that are attacking the tree. These defense mechanisms, honed over millennia of evolution, highlight the resilience and adaptability of trees in the face of constant environmental challenges.
While trees in forests thrive in interconnected communities, urban trees often face a more solitary existence. Planted in isolation, surrounded by concrete and asphalt, these city-dwelling trees lack the social connections that are so vital for their well-being. Imagine a lone tree standing sentinel on a busy street corner, its roots confined by concrete, its branches reaching out towards the sky, longing for the companionship of its kind. This lack of connection can have detrimental effects on the health and longevity of urban trees. Isolated trees are more susceptible to pests, diseases, and environmental stress, and they often lack the support of a thriving fungal network. As we continue to urbanize our planet, it's crucial that we consider the social needs of trees, planting them in groups and creating connected green spaces that allow them to thrive.
The intricate network of the wood wide web highlights the importance of forest connectivity for the health and resilience of our ecosystems. When forests are fragmented, the flow of information and resources is disrupted, leaving trees vulnerable and isolated. Imagine a highway cutting through a once continuous forest, severing the underground network and isolating tree communities on either side. This fragmentation can have cascading effects on the entire ecosystem, disrupting animal habitats, increasing the spread of diseases, and reducing biodiversity. Protecting and restoring forest connectivity is crucial for mitigating climate change, conserving biodiversity, and ensuring the long-term health of our planet. By creating wildlife corridors, reducing deforestation, and promoting sustainable forestry practices, we can help maintain the intricate web of life that sustains us all. The discovery of the wood wide web has revolutionized our understanding of trees and their vital role in maintaining the health of our planet. It's a stark reminder that we are not separate from nature, but rather intricately connected to it. The next time you walk through a forest, take a moment to appreciate the silent conversation taking place beneath your feet. Listen to the whispers of the trees, the rustling of leaves carrying messages on the wind, the gentle hum of life interconnected. Let us all become stewards of our forests, advocating for their protection, promoting sustainable practices, and ensuring that these vital ecosystems continue to thrive for generations to come. The future of our planet depends on it,